Welcome to Zip Code, and today we are looking at another cup of code. It's been a while since I uploaded something for you guys, but I have something nice that I want us to talk about. Today we are talking aspect-oriented programming, and we'll be looking into how AOP essentially delivers some nice modularization in terms of logging and performance. So aspect-oriented programming is essentially another layer that Spring is offering us to be able to address some common functionalities across the board, such as logging, such as performance, security, allowing users to specific API calls or specific methods, and also transaction management. And those are concerns that are cutting across the entire application layer in terms of business logic and API exposure. So in this particular one, as an introduction, we will look into just logging and performance, as I have highlighted in the title, because the other call them aspects, such as your security and transaction management, they have some more complexity into them. So this will be more pragmatic explanation and coding as opposed to just going into the theory of it. But essentially, looking into the Spring Initializer, I've already configured the project over here. I do have the project repository available on my GitHub, so if you do go there, you'll be able to find the project in the AOP microservice. So you can pull the same code, start using it. It already has the aspects defined, the advices that I've made available over there. We should go through in just a few, but it is available. You can pull the code and start seeing how AOP can be quite helpful on your scenario. So if you're interested in me doing security and transaction management AOP implementation, please do comment down below and I'll be happy to add all of those. But for security, we will need Spring Security. And then for data, for transaction management, we will need sort of like a database interaction, JPA, and things like that. And then we can implement those other two aspects of AOP. So having that being said, one thing I would like to request of you is to please do like and subscribe, and please do share the tutorials to anyone that is learning Java, Spring Boot, and they are willing to, or they are looking for someone to assist in their project. So let's get right into it. Spring Initializer project details. It's Maven based. The language is Java. Spring version, always take the latest stable version. So we have 3.5.4. Project metadata, always com.zip code. Artifact, AOP microservice. It's a demo project for Spring Boot. Packaging is a jar, and the Java version is 17. Although I think going forward, I'm going to start using 21, but 17 should be fine because it's an LTS. We are good to go. Couple of dependencies, not a lot. We pretty much need just the Spring Web. We're not really using Lombok as much, but it's always nice to have in case there's a project that you want to spin up. So Lombok will come in handy. And then we have dev tools for live reload if we make some changes on the fly on our code base. So let's jump right into our IDE. There is a dependency that is missing here. I'm going to show that in the POM file. So let's jump into IntelliJ and see what that looks like. So I'm going to start on the POM file just to highlight the dependency that we are missing, and that will be AOP aspect itself. Yeah, this one here. So this is the Spring Boot Starter AOP, and that's the only one that you would need to add. And let me just see. Yeah, that should be it. and nothing else. Actuator, you don't really need that. You can have it. It's always nice just to check the service health, but it's not required for this particular um, project. So in the application YAML, there's nothing happening there. I'm not defining any logging level or any log definition or any actuator exposure. It's just the application name, and that's about it. Everything else is just going to be defaulted by Spring. And then in the main class, I am adding an annotation over there. So please note of this annotation to enable aspect J auto proxy so that when the aspects define all the join points, they actually create proxies for the different beans that need to be intercepted, and then it will perform whatever logic that you have on your join point. So let's go into our business logic. We're going to start on the controller. So we have a REST controller over here, and you have a request mapping of API car. So if I try to execute this, let's say maybe run this HTTP request, you see that it's going to run here and it's done. And if I go to the logs, let me just go to all the way to the bottom, and you will see that there's some logs that are happening here. Actually, let me restart the application so that you can see that we're gonna start it from scratch. Then I'm gonna run this particular endpoint, which is we only have one endpoint over here. It's just a get find all cars, and that's it. So in the get cars, you will see it's a list of cars. There's nothing fancy that's happening there. It's hard coded, so there's no really like a database sitting under that. So I'll show you in just a bit. So the application is coming back, and let's just wait. Why is it taking forever now? Okay, let's give it some time to do what it does best. But in the meantime, you see that this is like a simple plain implementation. There's nothing complex about this. We just have our business layer here. We have our business layer here, which with the dependency injection of car service, and we get the cars from car service.getCars, and it gives us that. Let me see, the application started successfully, starting completed, right, started successfully. Okay, so the application is available now. So if I run this API, it's generating the request, and then we will see just now what's going to happen here. All right, so let's just do, okay, I'm just going to remove this one, it's fine. And I'm going to trigger this localhost 8080, and I'm just going to remove this guy, and our API call is done. Then when I come back here, you will see that after the application is started, completed initialization, there are some logs that are happening here: entering method, performance in method, exiting method, exiting method. So all of these logs, if you look at this, if you look at this endpoint here, this get endpoint, there is no log that says entering method, there's no performance in method, there's no exiting method. And if I go to the get cars, you will see that in the same way, there is no logging happening anywhere, and I am not having any system printout or anything of that nature. So what is actually happening here? So if you look on the project file, this side, there is this configuration package, and I have a logging aspect and a performance aspect. So these logs that I am printing out here, they are actually coming from these two configurations. So we're going to look into these configurations in a bit. Let's go back to our controller. So let's say you have an API controller, or you have a number of APIs in your application, and those APIs perform different functionalities. Like on a basic API, a normal basic API, you typically have a CRUD operation: create, update, read, and a delete. So you typically have these four operations. However I structure them, it's not really of a concern, but you typically have those four. In our case, this is just to showcase how you can use AOP. So over here, say in when I hit an endpoint in my API, right? Let me just do like an example here. We'll do, let's have a post mapping here. And then let's make this, it doesn't really matter, let's just make it as generic. And then we'll say create a car. And then would have another one, which is, let's say maybe this is a put to update a resource, and we will also have a delete, which will then be of the same nature. Say delete delete car, something like that. And then over here we'll just say update car, right? So typically you would have something of this particular nature in your API, right? Now if you have a big service, or with a number of scenarios, business cases that you need to cover on your microservice, then you would have to implement this logging in every single method of that is being executed at that particular time. So think of it this way. So in here, we would have to, let me just see if I plugged in self4j. So let me just add self4j so that I can be able to log this. So I would have to then log info, and then over here, I would say entering method. And I would also have to go and do the same thing over here. Then let's say maybe return now. That should be fine. And then over here, I would have to do the same thing again. Return. Let's just return a null here. And also over here, I'd also have to do that. Return now. Now, this on its own is not an issue, right? But you have to write all of this across the board for all the different APIs that you'll be exposing. And also, you might want to do that in your business logic layer, adding all of this logging that is lying around and not doing anything except just logging that you're starting to execute a method, you're done executing a method, how long the method execution took, and things like that. So in a nutshell, AOP offers us the capability of removing all of this manual labor and creating all of this logging lying around for no particular reason into a different standalone sort of a module or a layer that enables us to still have the same behavior, the same result with much less effort and ease of implementation. So that is what we are going to see now. So having said that, now let's go into, I'm going to remove all of these. And I'm also going to remove this because our aspect already does this. So now having said that, we just have our API here. There's no log defined, there's no system print out, there's nothing over there. As soon as we hit the endpoint, our business logic layer will kick off the get cars, and get cars is clean to do the business logic and nothing else. So it goes back to our solid principles, right? We want to make sure that we're only doing what we're supposed to do and nothing over that. And that's what we are doing and what we are seeing here. we are getting a list of cars. You'll see that we have the list defined here. We add all these different cars, and at the end we return that list of cars. And in the same way, we are logging the method execution as it starts, as it progresses, and as it completes or returns back a result. So now let's see how that is accomplished. So we're gonna go to the logging aspect, and you will see in the aspect at the top of the class, we have the annotation add aspect, which then tells Spring to register this bean and also have a proxy for all of these point cards that you see here. And we also have our join points that are defined here to handle the advice that needs to happen when we trigger these point cards defined at the top. So we have the aspect annotation, and we have our configuration to make it a Spring Bean. Then we have our self for J, which is to log anything that we want to log at a particular point. Then over here you will see our add point card annotation. This point card defines the expression that we want to be followed to intercept any class or method in this particular expression. So if a class or a method fulfills this particular expression, then we want the aspect to intercept that particular execution and then perform this particular operation that we would have defined in our join point over here. So let's see what that means. So we have a point card, which then means execution. We have an execution here. We have different point cards, but for the sake of this introduction, I'm just going to stick to what we have here, which is execution. So in here, we want to watch out for any execution within this particular package. So everything inside this particular package, all the methods in there, we want to watch out for those. So this is all methods are point cut. So every method you will see in here, the parent package is com.zipcode.aop underscore microservice. So essentially everything in my project you will see is inside this AOP microservice package. So if there's anything outside this AOP microservice package, that will be ignored by this particular point card. It wouldn't touch any of those classes or methods if they're outside of this particular package. And then in the same way, the second point card is in the parent AOP microservice package. But if I want to say, watch out for anything in the service package, for example, then now this point card will only intercept executions that go into the service package, and anything in here. So you'll see this particular annotation at before. So I have my at before advice here, and this advice will execute when that is true. All methods in specific package, which is this expression over here, and we are focusing on service, which means this before will only execute when I call get cars here. But if I call any other thing like the find all in this controller, it won't print anything before this execution. It will only print something on this before this particular execution. So let me just show you that quickly. Let's go back there. Let's come back here. I'm gonna save this. Then I'm gonna wait for DevTools to do its thing. If it doesn't, then I might need to assist it. So I'm just gonna bounce the application quickly, and you will see that this particular method will only execute when when a method in this particular package, all the classes in this particular package, it will execute for those guys. So let's see if the application can come up quickly. and we'll run that. But in the meantime, just to go through this, so in here you'll say before, and that before means before this business logic kicks in, this is what I want to do. So intercept this particular um, expression that is fulfilled in my logic or in my code base, intercept that, and this will be the point where the proxy kicks in to execute all of this code in here and then return back to the method execution. So the application is coming up whilst we wait for that. So you will see that in here, the join point is what we pass in to say, now we have met the point cut that we've actually defined, which is the join point that we have. And from the join point, we get the method name, we get the class name, and we get the arguments if there are any. So based on the signature of the method that we've highlighted in our point card, we will be able to get all the metadata before executing that particular method. So that is what we are doing here. We get the name, the class, the arguments, and we then log all of this information to say, you can actually say starting method execution, and then you say the method name, and then with arguments, those arguments over there. And this will now execute for all the methods within the business layer, which is the service package in our case. And you don't need to add this manually across your heavy, large, and massive business logic layer. You just have one method defined only once, and it handles all of that for you. And that's the power of AOP. That's what we are seeing here right now. So if I now just trigger this endpoint, let me just run it. Then I go back. So you'll see there is entering method with arguments, no arguments. So it has the get cars, but you don't see a printout of entering method find all controller. You only see that at the exit over here, which means what? This entering method has a point cut that is not fulfilled by the controller class, but it is fulfilled by the get cars because it belongs to the service package just as we defined over here. So anything in the service package, which is the car service.getCars, it's going to be printed out because it meets the point cut expression, and that is then printed out, or this particular logic is being executed. So with that in mind, we're going to see some other advice or advices that are available. So we have add before, which means at the beginning of this particular point cut. And then we also have the after returning, this is executed after the method completes. And then we also have after throwing. So after throwing is if there's an exception that is thrown by a particular method, then this point cut will be met. And you will see that there's a different way, there's multiple ways of defining point cuts. You can have them expressed this way, or you can also have them in the join points over here, and you can define them at this advice level. That also works as well. And then you have the after throwing, which is what I've highlighted just now. So if I can, let's say for argument's sake, I go in here and I go into that and I say, let's say over here, I throw like a runtime exception. Let's throw an exception and just say test uh, throw, let's say, test after throwing advice, right? And then it should be fine. Then we do that, right? So this guy is going to complain, and we need to add this to the signature. And likewise, in the controller, we sort of have to, we already have a try catch, so that should suffice. We don't need to add anything there. And then I can bounce this because my DevTools is taking forever to pick up my changes. So now that I'm throwing an exception here, you will see that this particular advice will actually be logged at error level. So there will be an error exception method, and it will highlight the error message that was thrown. And in our case, we just wrote test after throwing advice. That is what we ran over there, and we should see that coming through via this advice over here. So this guy is taking forever. Okay, looks like it's coming up. But yeah, guys, if you are happy with this introduction and the tutorial, please do like and subscribe. Really appreciate it to keep on doing what I'm doing. Just mentoring more developers and making sure that you know the most that is required in your dev journey or dev career. So please do pop those messages in the comment section if you have any questions, concerns, or comments. Those are always welcome as well. So let's see this. Okay, exposing, and now to get started, and that is done. Let's go to our controller. Let's trigger this guy. Let's do generating request, and now it's going to generate this thing. I just wanted to trigger the API, not actually do that, but that should be fine. And I'm just going to remove that. I'll trigger this, then I'm going to close that. So we got a 500 response, which is good because we threw an exception, so that is expected. In our try catch, we throw an internal server error, which is a 500. That is good. Then we go to our logs and look at that. Now we have errors showing there, and the printout is test after throwing advice, and you will see that the thrown exception is exception method with return value, that exception test after throwing advice over there. So if you go to our aspect, that is what we wanted to print out. So we have our exception method. Our exception method is printing over there. And we're able to handle exceptions that have been thrown and see and have our custom behavior that we would want to handle. So you can basically use this for your specific implementation. And if you have any challenges, please do let me know. And then the last one to check is the performance aspect, and we're going to that particular aspect over here. And you will see that across all these printouts, there is the performance one. Let me just go back and remove this exception here. Right. Cool. Let's save this. Let's bounce this whilst I explain the performance one. So if you go to the performance aspect, you will see from the top we have the aspect annotation, we have the configuration annotation, we have our self4j, and we have our point card defined over here. You will see the same thing, execution within the AOP microservice dot service, which means we are more interested in the business logic layer, and we want to monitor or advise on every single method execution. So that is fine, and we name this our business logic method performance. And we have a different advisor here. at this particular point, and you will see that this is at round. So which means this will track the start, the processing or the execution at the return or the completion of that particular execution point or a method. Um, so this will basically perform all of those combined. So in here, you will see what we do. We have our proceeding join point, and our proceeding join point, we get the method name, we get the class name, and what we do in here actually, we get the system time, or the start time rather, from the system.current time millis as long, and we just say join point proceed, which means this will be the execution of the actual join point. And then we want to see the end time, which is the system millis.current. And then basically we'll get this from the starting point of the method. Then we'll allow it to execute. And then we get the very end just before it completes for it to tell us how long did that take, right? And then because our method doesn't really do much, it initializes an array, sets a couple of values, and then return. We don't really expect it to take like forever, but in a much more realistic or pragmatic scenario, you would have these values having more meaningful values than what I'm currently doing. Let me just click that, and then let me just execute this, and you will see the performance printout being shown over there. So that is executed, and now we get a 200 OK. That looks good. And then if I go back to our logs, now we want to see the performance aspect. The performance aspect has the performance in method with all these details, and with time taken, start time minus the end time, or whatever the case might be. But in this instance, if you go there, you will see that performance in method is printed out over here with time taken -2. Obviously, I need to switch these around. So my end time needs to be here because end time will be greater than start time. This is fine. Start time, right. All right, so now that looks that looks proper. And then if I restart this, but essentially you get the idea. We got those 2 milliseconds as in time taken, and we're able to now understand where the bottlenecks are across all the methods in our business logic, and would know which methods require optimization based off of these particular aspect that we've defined and advice that we've defined over here. And we're able to know how to then go about fixing those to meet the, maybe let's say, the threshold times in terms of performance. What is the average time you'd want to see your methods taking and not take longer? So if you have things such as database operations, let's say API integrations within your business logic, you would then understand based off of this performance aspect to see where the issues might lie and where to optimize your logic accordingly. So with this particular one, I wanted to keep it short and sweet and also as much as detailed as possible. I hope this is helpful to you, and I hope that you got the introduction to understand what this what AOP is all about and how it basically assists in optimizing and cleaning up your code to get the best and maintainable code going forward. There is the security piece and the transaction piece that I haven't touched on, but there are 2 critical aspects that need to be spoken about. If you're interested in those, pop a comment down below, and I will basically do an entire tutorial around those, because I need to add Spring Security dependency, database dependency, JPA implementation, and then we'll have those transaction management aspects to share as well. For now, please do like and subscribe. And until next time, for this one, cheers.